Hello everyone and welcome back to this final part of the Python Crash Course. And in this part we'll discuss functions, lambda expressions, we'll talk briefly about the map and filter built-in functions, and we'll go over a couple of useful methods off some of the data types that we discussed. Let's get started by talking about functions and basically how we can create our own functions using Python. So to create your own function using Python, you start off with the keyword def to define your function. And functions are going to be lowercase, so we'll just say something like my_func, then close parentheses, colon, and then you have the block of code that will execute whenever you actually call your function. So remember, a function is basically just something that allows you to execute a block of code over and over again without having to rewrite that entire block. You just call it a single function. So we'll have it say something like print hello. I run that to define it, and then if I call my func, it executes hello. So what else I can do with a function is add in parameters. So I can have a parameter here, we'll just call it param, and then inside of my function I can actually have param. So what does this actually mean? Well, it means that my function accepts a parameter or some sort of argument, and then we can use it inside the function itself. So if I run this, if I try running my func again, it's actually going to give me an error. It's going to say, hey, I expected one required positional argument, param. So it requires this argument or parameter, so let's provide it one. We'll just give it Jose, and now it just prints out Jose. So that's the way you can create a function that has parameters. You can also set default values for parameters by just setting equals and then some sort of default value. So when your function has a default value, if you run it with a value that you provide, it will overwrite the default. But if you don't provide it with anything, it will just go to the default value here. So another thing we can actually add into this function is the documentation string. So you've seen documentation strings by using Shift-Tab. If you want to add in your own documentation string to a function, just have a set of triple quotes, and you'll notice as you begin typing those 3 double quotes there, Jupyter will automatically fill in that, and that allows you to write in a multi-line string where the doc string will go here. We'll say doc string goes here, and then I can rerun that, and if I call my func, I end up getting default, but if I have my cursor inside of this and do Shift-Tab, I get to end up seeing my documentation string where it just says doc string goes here, and it also tells you what the parameters are and what the default values for the parameters are. So whenever you're calling Shift-Tab, it's going into whatever library you're using and reading off those documentation strings and reading those parameters. So notice here, this function was just printing the parameter. Usually you won't have a function just do simple print statements. What it's going to do instead is it's going to actually return the parameter, so, or the argument. Let's just call this argument, and in here we'll take in an argument, and we'll expect the argument to be a number, so what we'll do is we'll just say times 5. So we have that, and then when I call my func and pass in 5, what I can end up doing is saying x equal to my func, and then when I type in x, it's now returning the argument times 5. So this is different than just printing it out because the return statement allows me to return it in order to save it to a variable later on. So usually when you're using functions, you'll want to return whatever final calculation you did. So after you call the function, you can actually get it back out and save it as a variable. And then once you have that variable, then you can feel free to print it out if, for whatever reason, that's what you want it to do. All right, so that is a function. Now, sometimes you won't want to actually define an entire function. So a specific use case for this is when you're using the map and filter built-in functions, you'll want to actually use what's known as a lambda expression. That's our second topic here. So a lambda expression is known as an anonymous function, and what it allows you to do is quickly create a function to use one time that has no name. So let's create a normal function, and then we'll show you how to create an anonymous lambda expression. So we'll create a function called times_2. It takes in some variable, var, and then what it does, it just returns that variable times 2. So when I call times 2, let's pass in 4, save that. We'll save that as my result. And then if I check out my result, I get back 8, because 4 times 2 is 8. If I only intended to use this one time in my script, it may not make sense for me to write out an entire function. And instead what I can do is use the lambda keyword to write what's known as a lambda expression. So the equivalent lambda expression for this would be keyword lambda variable colon var times 2. So this would be the similar lambda expression version of this function. So let's actually break down how we can convert this function into a lambda expression. And then up next, when we talk about map and filter, we'll see why lambda expressions can be useful. So to break down this top function into a lambda expression, we do the following things. A lambda expression will use the lambda keyword instead of the DEF keyword, so we can just delete that. And then we know a lambda expression won't need a function name, so we actually remove that as well. And then we can remove these parentheses. And then instead of just returning something, since by default we know we're going to return, we just end up typing this. And then we replace the DEF with the keyword lambda, and now you have the lambda expression. So let's kind of show those steps one more time, what's actually happening here. We take away this DEF keyword, change it to lambda, we take away the name of the function, and then instead of having a return, we just put whatever you're going to return back on the same line on the other side of this colon. And that's how you can convert a function into a lambda expression. Now, this by itself isn't super useful, but it's really useful when you're using it with other functions and you want to pass in your function as an argument. So let's discuss map and filter in order to show why a lambda expression would be useful. And we'll be using these all the time with the library known as pandas. So I'm going to create a sequence of numbers. We'll say 1, 2, 3, 4, 5. And then what I'm going to do is use the map function. And this is a function that's built into Python. So we can do Shift Tab on it, and we can see that it maps some function to some iterable sequence. So what does that actually mean? Well, what we can do here is say pass in our times 2 function that we had earlier, and then pass in our sequence, seq. And we see here it returns back this map object. So if I want to see the result of this, I can cast that to a list. And then you'll notice that it took our times 2 function that we defined earlier, and then it said, okay, apply times 2 to every single item in this sequence. And then we cast that to a list, and we get back 2, 4, 6, 8, 10. So again, all it does is takes in a function and applies it to a sequence. Now maybe you only intend to use times 2 once on this sequence. So instead of going through the entire process of defining a function with DEF keyword and having a docstring, etc., you can replace times 2 by its equivalent lambda expression that we defined up here. So we'll say lambda, some variable, and then return multiplying it by 2. And if we run this, we get back the exact same result, 2, 4, 6, 8, 10. And you can actually call this variable whatever you want. So just like in a for loop, it can be just some temporary variable name. So you can say num and then num times 2, and that's your lambda expression. So that's how you can use map with a lambda expression. The other function I want to talk about that's built into Python is filter. And filter, again, takes in some function and then applies it to some iterable. But the difference between filter and a map is that this returns an iterator yielding those items of an iterable for which the function item is true. So what does that actually mean? Well, we're going to have another function. We'll say DEF, and we'll call it isEven. And it takes in some number, and it's going to check if it's even or not. So we're going to return if the number mod 2 is equal to 0. Remember, number and mod 2 just indicates what is the remainder after you divide it by 2. If you divide a number by 2 and the remainder happens to be equal to 0, well, then you know it's even. So this returns either true or false. True if the number is even, false if the number is odd. So we'll run this, and then we'll say filter, pass in isEven, and then we'll pass in our sequence. And if you just run this, you get this filter object. So to actually see the results, you'll have a list here. And then we get back the even numbers of our list. Remember, there was 1, 2, 3, 4, 5. The only even numbers were 2 and 4. And this is another situation where we could use a lambda expression. So see if you can pause the video and replace isEven here with an equivalent lambda expression. All right, I'll walk through that right now. Instead of saying DEF, I'm going to say lambda. We'll take away isEven. We'll take away the return keyword. And there we have it, the equivalent lambda expression. So then I just copy this and paste it in here, run this, and then we get 2, 4. So when you're new to Python, if you just see this one line here, it kind of looks a little bit crazy, but this is actually normal Python, some efficient code, these one-liners. They pop up a lot, especially with some of the libraries we're using, so it takes a little bit of time to get your mindset adjusted to these kind of clever one-liners, but once you work with them more and more and get more comfortable with Python, it'll start to feel a lot more natural to you. Again, don't worry too much if this felt like an overload of very specific Python things. You'll get enough practice as we go along through the course that by the end, you'll be a pro in this. Okay, finally, I want to just discuss a few simple methods that you may find useful as we continue on through this course. The first ones are just string methods. So if I say, hello, my name is Sam, I can make sure, well, let me change this so that S is capitalized. There we go. One of the methods I can call to lowercase everything in a string is just st.lower, and that will lowercase everything in that string. Likewise, I can call st.upper, and that will uppercase everything. And note here that in order to actually execute this, I need to call these parentheses. If I just call it without, it'll just report back, hey, this is some function here that you haven't called yet. And then when you run this, then you've actually called it. And the last method I want to show you for a string is the split method, and that one's pretty useful. So let's create another string. We'll call it tweet, and this will just say go sports, hashtag cool, something like that. Now you can use the .split method to actually split on particular spaces or characters. So if I say tweet and then call the .split method on this, what it ends up doing is by default it splits on the white space of this string and returns back a list of everything split on the white space. So that allows you to actually get back a list and then iterate through every word in this string. Now you can actually split on whatever character you want. So if you wanted to, you could split instead on the hashtag and run this, and then it will split on the hashtag and it'll give you back go sports and then cool, which then allows you to kind of grab stuff from this list. So then you could do indexing off of this, maybe index for 1 that returns back cool. So again, this is very kind of Pythonista code here. Split is very useful. Now there's a bunch of other methods available on strings. If you want to see them all, just off of any data type, call dot, and then you'll see the .tab, and then you'll see the list of methods. A lot of these we won't ever need to use, but just keep in mind they're there for you in case you need them. Okay, so those are useful methods for strings. If we look back at our dictionary that we created earlier with key 10, key 2, 10, and second item, if you ever need just the keys or items of a dictionary, what you can end up doing is you can call d.keys, and this will return back kind of a list of the keys, key 2. Remember, they're not going to be returned in any sort of order. If you want the actual items, it's going to return back a tuple, a list of tuples, with the item pairs. So it'll run key 10, key 2, second item, in case you ever need that. So those are some useful methods off a dictionary. You can always explore more of them by saying .tab, and here you can see the list of methods and attributes that you can call off a dictionary object. Won't be using those too often throughout the course, so don't worry about it too much. Okay, finally, for a list, so let's create some list. We'll say my list is equal to 1, 2, 3. Run that. We already know that we can call .append on a list, and that allows us to add something to the end of the list. So now if I check out my list, I see 1, 2, 3, 4. If I ever want to remove an item from a list, all I need to do is say my list, pop, and that will remove the very last item in a list. If you want to remove an item at a certain index location, you just pass in that index location to pop. So we can say mylist.pop, and that removes 1. Keep in mind, this does take a permanent effect on your list, so if I call my list now, it no longer has 4 or 1, it just has 2 and 3. And the very last thing I want to talk about is checking if an element is in a list, and you can do that simply with the in keyword. So if you want to check if the number 1 is in my list, you just need to run this, and it will return back true or false. So if I want to check if 2 is in my list, it returns true. Likewise, I can do something like, is A in 1, 2? That's going to return false. If I add in A as an item in that list, then it returns true. Alright, and this concludes this quick Python crash course. Coming up next is going to be a quick overview of the exercise notebook, and then after that we'll go over the solutions to the exercise notebook. Okay, thanks everyone, and I'll see you at the next lecture.